Hey everyone, and welcome in. My name is Stephen Robb. I'm a partner solution architect here at DBT, calling in from San Francisco. And today we're going to talk a little bit about delivering AI and how DBT kind of makes that a little bit more accessible and possible. I'm going to be joined today by two other speakers. You're going to see Dustin and Dakota from phData. If you've seen a couple of our past webinars, you understand how this goes, but I've had the pleasure of working with them a few times now. So now let's cover some basic housekeeping. So we're going to have a Q&A tab for all of your questions where a DBT product expert will be able to answer them. For the chat, feel free to throw in some banter, connect with people, highlight what you've learned from the presentation, or just share where you're from too. Etiquette, just, be respectful and be inclusive. Feel free to ask tough questions, provide some feedback. We'll send out the recording after 24 hours after this event. And then we'll also share a survey to let us know how we're doing. So for the agenda today, we're going to start by covering the AI context gap, kind of some of the challenges that we see DBT being able to assist with as we kind of move into this AI workflow, AI world, really. We're then going to have a customer journey and a demo from phData. Then I'll share a little bit about what's coming next in 2026 with DBT agents and some next steps for some additional webinars kind of on their way. So first, let's get started with this data engineering in the AI era. So AI is changing how we use data at a pace we've never seen before. Like we all know, like there's a new tool every day. You got to redo your entire workflow. We've never had to learn as much as fast as this, I feel like. Data engineering teams once kind of focused solely on the pipelines and the transformations are now really on the front lines of AI strategy. They're expected to deliver intelligent, reliable data products and do it faster than ever before. And somehow, at the same time, they need to make sure those systems are trustworthy, scalable, and secure. So, just as DBT revolutionized data transformation in the cloud era by adding all these better processes around the ETL, like modular, version controlled, testable workflows. Um, Now we're trying to do the same thing in the AI space. So we're becoming this standard for delivering AI-ready data infrastructure in this kind of new era. And so while our customers are moving incredibly fast, building everything from agentic workflows and internal copilots for kind of like customer-facing chatbots, the underlying kind of AI stack is changing even faster. So each week there's a new breakthrough, there's a new model, a smarter framework, or even a new vector store. And so like that velocity really means that AI and data teams are constantly adapting from going from Claude to Cursor, Pinecone to semantic layers, and retraining systems just to kind of keep up. So each of these shifts is introducing friction, new integrations, rewrites, tuning, duplication. There's a lot of time, risk, and really just slowing of innovation caused by these like wide variety of tools. But at the end of the day, a lot of the kind of fundamental questions are the same. So like, what does this metric mean? Is this definition still up to date? Where did this number come from? Or even like, can we trust this data really? For enterprise AI, the bottleneck isn't compute power or data volume. We would argue that it's context and basically like structured, governed context. So large language models can't just reason over raw or fragmented data. They need that strong foundation. So like without those structured definitions and shared business logic, these AI systems kind of have to do like what an intern would do, and they get kind of stuck guessing. And when they guess, they start hallucinating. And that's where you see all the data problems of asking a question and getting the wrong answer. So for example, take like an internal chatbot. You might have a user that says, what's our revenue for enterprise customers in Q2? And to be able to answer that question, the model has to understand a few things. What defines an enterprise customer? which up-to-date table or model includes revenue logic? And does that revenue table have cancellations, ticket sales, or returns? Or even is there any other things that needs to take into consideration for how you answer that question? So without that structured governed context, the large language model might generate SQL that runs, but it might also return the complete wrong answer with complete confidence. So you would think that the machine is correct without you actually being able to validate it. Or consider an agentic workflow generating an entire weekly order summary. Without a version control definition of order, it could be pulling that definition from the wrong table. It could be double counting some of those returns or just blatantly missing critical logic. So basically, again, giving you incorrect results with a question as simple as what was my revenue last quarter? And so what we found is that what's needed isn't necessarily more tools. It's kind of like a unifying control plane for your system, your AI systems. So really, it's going to be one place where your business logic, your transformations, your tests, and really your documentation live. Structure it once and then apply it everywhere. And that's where we kind of see dbt fitting in. With dbt as the control plane for your AI, you structure your data once and you're able to then use AI everywhere. So, as we just kind of said, these AI systems need access to structured context. And really, at the end of the day, that's primarily what dbt is the ability for you to be able to create data about your data that can then be used for querying, for AI, for all of these other use cases. And those AI systems are going to be able to pull that context so that basically we can get to a more centralized, governed platform and workflow. The idea there is that we can remove a lot of that context that exists in fragments or tribal knowledge and now lock it down in code so it's reliable across your entire organization. And so while dbt is already the standard for creating high quality governed data sets from your warehouse, it captures rich metadata, model lineage, test coverage, centralized metric definitions, all those kinds of important things that we talk about. It's also bringing something else. It's bringing performance and cost efficiency. So rather than connecting each AI workflow to its kind of own source, let DUT centralize those transformations, those metrics, those documentation, all in one layer, which should reduce, a bunch of your queries. You should have less compute spend because now we have a unified model where you can apply some of like state of orchestration, some other features, and you should also have a faster response time for your end users. It should become much easier for you to develop additional kind of workflows because you now have a unified platform to ask questions on that. And with something like dbt, you do get that cross-platform flexibility. So as you know, dbt works across Snowflake, Databricks, BigQuery. So you're going to be able to build fast across your entire stack without sacrificing any consistency. Another really important thing to note there is security and governance. It's one of the big things holding back, I'd say, a lot of AI projects. And dbt is going to help close that gap in that with every model, test, and transformation, we can validate that that's going to be logged, it's going to be versioned, and it's going to be auditable, which really means that we can meet a lot of those enterprise grade requirements for compliance and data protection with AI. And then lastly, as far as kind of AI powered workflows goes, you're going to be able to leverage this context to build better agents and better overall AI experiences faster than ever. And another thing to kind of bring up here is our MCP server. So while everything we've said so far has been more about providing the context that's required, how does dbt make it really easy for your tools to now actually integrate exactly with dbt? And that's where the MCP fits in, is tools like LangChain and Semantic Kernel can directly query dbt's semantic layer, lineage, and tested models via API so that your AI systems don't just access the data, they also understand it. And so while the AI tools may change, GPT-4 to Claude, chatbots to agents, your foundation shouldn't change, or doesn't at least doesn't have to if you're using dbt. And so this is a nice little diagram here of MCP and kind of what it is. Feel free to check out our GitHub repository for it. And what it's going to do, like I said, is really just unify all of the different dbt assets and AI applications. And we make that accessible for you in two different ways, both a local connection and a remote connection. With the local, it's pretty self-explanatory. It runs on your laptop alongside your DBT project. It's a fantastic option for local development with something like Cursor or Claude, and it means that your agent is going to make be more empowered than ever to basically create your DBT code right on your machine. And then the second option is to run it remotely. So we have an incredibly straightforward setup where you can now plug and play your dbt MCP server directly with any of your different AI tools and access them by any sort of like web application. So it just means that you can connect multi-agents, multi-user systems easier than ever before. And you're going to see a wide variety of MCP kind of integrations with a lot of our partners coming in the future. And then lastly here, before I turn it over to phData, a lot of what we've had so far has been kind of theoretical conversation, but I also wanted to support that with a real case study. So by introducing DBT MCP, M1 Finance was able to reduce their engineering bottlenecks and dramatically improve their efficiency. So their teams didn't really have to wait on specialized resources to move their projects forward. It gave them a really clear path to be able to reduce some of the biggest blockers of why they had failed to adopt AI, um, basically hallucinations. So with structured, validated access to those systems, the AI could act on some real authoritative data. And with that additional context, they were able to finally be confident that the answers and outputs that we're getting were accurate, reliable, and safe. Really letting them kind of unlock that true scale and not just like a POC or an experiment. And so with that, I'm now going to hand things over to phData, who's going to walk us through how this works in practice with kind of the sample company workflow.
All right, thanks, Stephen. Appreciate the information to carry over, and appreciate everyone here for joining us. Happy to be with you all. My name is Dustin Dorsey. I'm with the PhData team. I'm a director of data engineering here and one of our practice leads. And I'm here with my colleague Dakota. Dakota, if you want to introduce yourself and PhData.
Yeah, it's nice to meet everyone. I'm Dakota Kelly, one of the principal solution architects here at phData. Excited to be chatting with all of you about this topic. Just as a real quick introduction on who phData is, in case you don't know us, we are one of the top consulting firms out there to help implement, work through, and partner with your technology. We focus purely on data, whether that's helping you set up a data strategy, data engineering, data analytics, creating fusion teams, machine learning agents, all the different hot topics inside of data. We cover all across the spectrum and partner with the top technologies out there, including being the three-time back-to-back-to-back DBT Partner of the Year, on top of Partner of the Year with Snowflake, many times, and four-time Partner of the Year with Fivetran, etc. And so with that, I'll hand it over to Dustin to start to talk about this customer story that we're going to go over and give you a demo of.
Sounds good. All right, let's dive into it. So what we're going to do here is kind of carrying over. Stephen gave some of the fundamentals related to what we're going to talk about. What we're going to do is we're going to give you a customer example of a fictional story that we created just for this presentation. And then we're going to show you a demo of this actually being in action. But we're going to start over the next little bit just walking through who this customer is and then we'll dive into the demo here. So here we have a company, Galaxy's Edge Travel Company. They're the largest tourism operator in the Outer Rim. They offer a wide range of services, including Star Cruiser vacation packages, droid assisted lodging experiences, Lightspeed enabled transformation, and holotable concierge services. Imagine this company existing in your favorite space themed world of Star Wars, Star Trek, or Starfield for the gamers out there. of existing in this environment. And what they want to do, they have a goal, or they've reached out to a company like phData to say, hey, we want to build an AI concierge or a hollow guide, if you will. Think of this as a way cooler version of an Alexa or Siri or Google. And this Hollow Guide can answer any questions instantly. So things like pricing, availability, loyalty points, packaging rules, bundling, recommendations. Whatever you want to ask it, you just ask it what you want to know, and then it spits out the answers immediately to you and always be consistent. The challenge is they have the data for all of these systems, but it's scattered across multiple systems. So think of things like they have Star Cruiser manifest, which is JSON events that's captured from their hyperspace travel system. They have droid service logs, which are semi-structured information that they're loading up and getting into a structured format. Resort booking information, which is stored in structured tables. And then loyalty points balances, which come through microservice API dumps. While likely no one on this call works for an intergalactic travel tourism operator, some of these systems that exist here probably resonate with systems in your environment. So hopefully, as we go through this scenario here, you're thinking, oh, yeah, we have a system that does that that we need to pull in here. All right. So let's talk about the context gap. Stephen gave some information on this earlier, and now we want to make it a little more practical and understand here. So the Hollow Guide that we're building doesn't understand the business. So it's a brand new, it's an AI system. It can show up, but it doesn't know anything about our system. This isn't because the AI is bad, but this is just because our enterprise context is a mess. If we just go and we take all of this data into disparate systems and put an AI on top of it, it's not going to produce very good results. For instance, calculations like something like total trip cost is calculated differently across multiple systems, and so it can produce varying degrees of results. Room names, like if you're booking a room on one of our Star Cruiser packages, you may have some that are deluxe dash pod, D dash pod, or pod deluxe. And these could all indicate the exact same room, but AI doesn't know that unless we provide context to let it know that that's true. Also, loyalty tiers aren't joined correctly. This causes the AI to hallucinate discounts, and so we're not getting consistent pricing. And then lastly, packaging availability depends on arcane business logic, and so all of these things have to be taken into account to make sure that our Hollow Guide produces the right results and it's consistent with it. So the organization realizes, as we're going through talking through this, that AI is only as good as the structured context that we feed it. So what they need is a data control plane and a structured context layer built on something like dbt to provide that information to them.
Agreed. And that context is so important because that, like stated before, really allows the AI and the agents to truly be able to answer these questions and allow us to scale the data products we're building out to larger teams, allowing people, if they have a one-off question, to just ask it and get that answer instead of needing to request a new dashboard to answer a very small question.
Yeah, absolutely. And think about it, like we don't want our customers who are coming here speaking to our Hollow Guide asking for something like a ch child-friendly activity and then getting sent to a Sith temple, for those of you who are a Star Wars fan, because it's probably not going to be very child-friendly. So those are things we're trying to solve for. All right, so why DBT? Where does DBT fit in here? Why now? Well, Galaxy's Edge travel needs to pair to power their AI concierge with a few different things. First is the data modeling. And if you have followed these sort of sessions that me, Steven, and Dakota have done over the past several months, the last session that we did was specifically on modeling, which is really a prerequisite to be able to get to having this hollow guide that we need to build. So the modeling is creating consistent facts and dimensions for our trips, packages, customers, and Droid services. We need to curate this data. We need to put it in easy to understand manner by breaking our data up within facts and dimensions. The second thing is we need to create a semantic layer. We need to define metrics like total trip cost, just to give an example, like a total trip cost, occupancy rate, and loyalty eligible balance that are always correct. So we need to put that on top of it. The semantic layer will also is a place where we can define the joins for our model to help it understand how the joins are made. We can add business-friendly naming, and then obviously we can store calculations and metrics within the semantic layer. And then lastly, with the MCP server, this is how we expose governed DBT context directly to the AI agent. And in this case, it's our Hollow Guide. So that when someone asks the question, how many loyalty points will I earn if I add the Holocron Discovery Tour to my 3-night Star Cruiser stay? We produce accurate results. So AI must be reliable to be able to answer these questions. So in order to be reliable, what it needs to do is first of all, it needs to know the definition of what a holocron discovery tour is. It needs to pull semantic metrics on cost, loyalty accrual, and discount roles. It needs to join it to our customer profile or customer dimension. And then it needs to apply real business logic to it. And so it needs the context to be able to do that.
If you look at these things, they're almost like layers of maturity within your data products. Once you've built the model, it's not enough to just provide the fact and dims and call it a day. The semantic layer, like was stated, allows us to explain how these things are joined and what these things mean. On top of, we can add other more valuable metadata. It's not just here's a metric and here's what it means, but we can also go so far as to say, hey, here's multiple synonyms for this type of metric, and here's what people across the business or across the galaxy might call this, but mean the same thing. You build up that context, and it allows the AI to avoid those hallucinations.
All right, so let's talk about what we're going to demo. So now that we've established our customer and what our customer is trying to solve for and what they want to try to do, now we want to actually show it to you in action. Like, how did these components actually come together? So we're going to build an intelligent, context-aware AI travel concierge, and we're going to do it through 3 steps. First, we're going to focus on the data modeling aspect. We're going to build a small mart with a few fact tables and a few dimensions just to give something to work with. And then we're going to put a curated model for the demo on top of it that standardizes all of our package rules based cost dynamic fees. So we're just going to create a base level model, and Dakota's going to show this here in just a minute. Then we're going to put a semantic layer on top of it in which we're going to define some of the business metrics that the AI will consume, specifically things like total trip cost, package revenue, etc. So we'll show those. And then lastly, we're going to show you the MCP integration. So HoloGuide AI will use the DBT's MCP server to browse the semantic model, ask for a metric, query for the curated models, and then generate human-ready answers. And so then we're going to show you the power of it by asking some questions and getting results from it of what our really cool HoloGuide would actually produce here. And so with that, I'm going to kick it over to Dakota, who's going to jump into the demo and show you guys this stuff in action.
All right. Thank you, Dustin. As we get ready to kick off this demo. Again, as a big part of this demo, we're going to dive into using MCP. And we're not just going to use it with Visual Studio's code. We're actually going to have a very simple text-based chatbot going as well. But the core of this entire presentation is how MCP can improve the context of our LLMs, these other things. But for it to do that, we need to first understand what is our source data model? What transformations have we built? What's our final data model? What documentation exists? How do we document and ensure that that context exists in a way that can help facilitate the AI agent and the AI tools and the LLMs making the correct decisions? And to do that, just like we talked about, the very important first step is understanding source data as well as what our final data model is. You can see here, we have a rough ERD put together of what our source data looks like. We have a set of customers. Those customers have loyalty accounts, which can be a part of a loyalty tier. That customer also can have reservations. Those reservations have rooms. They can come from a reservation package. They can have items attached to them, as well as we have service logs of the droids that have gone in and done cleanup on these different rooms. And as we start thinking about the type of questions we might want to ask as business users, as well as what our customers might want to ask, we start to think, okay, probably one of the most important things is information about reservations. What reservations are available because the room is not booked? How clean is the room? Are we having problems with our droids not being able to properly service the rooms and take care of them? How do we make sure that those in the loyalty tiers are feeling sufficient enough discounts and other things to want to remain as a part of the loyalty account in their loyalty tiers? Those different pieces of information are extremely important. Because of that, we need to build out a data model that facilitates that type of analysis. And you can see in here, we have created a data model with a set of DIMs around rooms and customers, facts around our trips, around our trip pricing, as well as the packages that they're part of. When we create out this set of DIMs and facts, it becomes very easy for us to, one, put the semantic layer on top and use the semantic layer to define these different relationships, the joins that need to exist, what data exists, why it exists, what its purpose is, what the context of that is. That provides us an easy interface to query and get results and start to ask questions of our data and start to provide a natural language interface for getting results and understanding what's in our data, while at the same time reducing things such as the hallucinations. By understanding what our begin state is, which is the transaction system, and what our end state is, we can start to visualize and put together what is the path to get to that end state. That's where we start to build out our DBT project. You'll see it's a fairly standard project. We've got staging layers of all of our source data. Those get brought into intermediate layers to bring the data together, which then culminates in the set of facts and DIMs that we've created, as well as a set of semantic models. These semantic models define things like trip, as well as our trips pricing, things like the rooms, the customers, etc. With this context in place, we can do a number of extremely interesting things inside of our DBT project. We start to build out those layers of transformation, provide the context, provide the standards, provide the understanding of our models. Integrate that in with something like DBT's MCP server, which is able to communicate with your cloud instance, understand your DBT artifacts, understand the queries, the semantic layer that exists, etc. Help us provide an interface to improve our development workflow, as well as how we're querying, thinking about our data. So what does that mean for us? Well, if you have the DBT MCP server set up in your local environment, you can do something as simple as go on over to your chatbot here. With this chatbot, we can ask it to do a myriad of different things to help us understand our DBT project. Again, you'll see up here, if we look at the top, we have a very simple setup for how to activate our MCP, as well as our environment variable with our environment file with all the different appropriate variables to connect to our instance and understand what to do. Now we can do things like come in here and you'll notice I forgot to create my semantic layer for fact packages. I could come in here and say, I would like to create a semantic layer for my fact packages model. This semantic layer should follow the naming conventions and structure of the rest of the semantic layer files in semantic models. When I do that, this is going to connect to the DBT MCP and use that to help it understand the different things that are part of this repo, help it understand those different patterns, and generate the actual semantic file that is needed for us to be able to do semantic work with the packages. And what's nice is we've already provided a decent amount of context for fact packages because, well, if we go look in our YAML, we've already provided things like descriptions, tests, and other things like that to provide as context. We can see it already coming through in the different descriptions. We can use this to create new semantic models. We can use this to help us improve our performance. We can automate some of the minor boring things, or at least start to put things in place that help us move faster. But that's not all the MCP server does. Again, it takes all that context and we can start asking it about our data. What sort of things might we want to know? Well, let's go see how our droids are doing when it comes to interacting and cleaning up the different rooms. I'm going to ask it. And by the way, this is connected to GitHub Copilot. Using the semantic layer, what are the droid success and failure rates for servicing trips? One of the things you'll see is it's going to actually query the semantic layer. It's going to ask me if I like that query. We're going to let it go ahead, run the query. It's going to provide this. And we see that we're actually having quite a high failure rate on actually servicing and taking care of the rooms. About 1 in every 5, almost a 20% failure rate. It's not great. That could mean we have unclean rooms, they're not getting taken care of. Could mean that there's problems with our droids and we should take care of them so that way rooms can be serviced for those who come to see us. This is a great way for us to find and identify these sort of things fairly quickly. And if we take a look here, we'll see that a lot of this is tied to just having the semantic layer in place, having those things executed inside of DBT, having those artifacts exposed out there for the MCP server to go communicate with that server and bring those results back. But this isn't the only one that we could do this for. We could also ask, using the semantic layer, what is the average base cabin cost, package revenue, tax, fees, and loyalty discount applied for each loyalty tier? Again, we can build out this very complex set of calculations. We can see it's able to go over there. It's returning and going, hey, here's the command for me to go query the semantic layer, for me to go return those results and group them up appropriately. We have it grouping them, breaking them down, providing those results. We can see it even generating a set of insights based off of what it's seeing in that chart. What are the different loyalty tiers? What are they paying? What's their package? What's the tax that they're spending? The average fees, the discounts those are receiving. We can see here that for the most part, the loyalty discount seems to be heaviest once you get into the Jedi and Master area. And so we need to make sure that we are letting those in Padawan realize how much they're missing out on by not paying to be in these upper tiers of the loyalty service. This helps us identify those types of things. And again, it's able to do this due to all the context that exists. And you're probably seeing this and going, That's great, but that's in my IDE. It has nothing to do with the Hollow chatbot. The chatbot isn't the only place we have to do this. This DBT MCP is a package out on PyPy. We can install it. We can utilize it with other things like LangChain or OpenAI and these different tooling, whether it's strands, etc. Pull these together to create chat interfaces that we can communicate with. As an example, I threw together a very, very simple chatbot here, and there's examples of these inside of the DBT MCP repo. If I go ahead and run my chatbot here, it's going to start up my environment. I have a little terminal. This is the Hello chatbot that we were talking about. Well, what is this made of? If we come down here, we actually have a bunch of different parts of MCP that have been brought in and OpenAI. And this one's using OpenAI to just interact and create a chat stream, interacting with MCP, feeding information between the two, and allowing me to have a chat interface. This allows me to start to ask similar questions that we could start to put in the hands of our business users or into our customers. Using the semantic layer, what loyalty, it helps if I spell it correctly, tier receives the best discount. Again, this is using totally different interface. This is using OpenAI. Ideally, we see a similar thing that master is the one that comes back as having the best loyalty tier. We can see it interacting, calling the different parts of the MCP server, returning the metrics, analyzing which metric to use. As it's going through this, it will return a set of results. And it is saying that there is roughly a 15% discount rate for master. And it recommends that as the best loyalty tier. Now, we don't get the 15% discount rate by looking at our average base cabins information over here, but we do see that master is the highest. And so we are seeing these things are relating, they're making sense. The results that we're getting from the bot line up with what we see out here, as well as if I go query the data. This allows us to generate that interface by using DBT's MCP server to understand the context of our DBT project, connect to the environment, query the DBT semantic layer, do searches and lookups on those things, and understand what is out there and what is available to us. Provide answers, utilizing our transformations and all the context we've put in place on that by, again, utilizing the semantic layer to explain how does our final data set connect? How does the different attributes across the dims and the facts join up? How do we wish to calculate those different metrics that we want to utilize? What is the documentation of that information? Relaying what exists, why it exists, what its purpose is. This helps us provide governed answers while reducing our hallucinations with our data sets, all utilizing DBT's MCP server. Again, connecting to our DBT instance, executing our code locally to help us be more efficient with our workload and help us provide better context to the large language models that we use, regardless of whether we're using something like a Copilot to improve our development workflow or trying to create a new unique customer experience that makes it easier for our customers to get answers and understand what is going on, such as whether or not they should upgrade their loyalty tier and if the upgraded discount will be worth it. And so with that, I know there's a lot of stuff here. There's a lot of things to see here. Go look out at the DBT MCP repository. You'll see an examples folder with a lot of these different examples out here that you can start to experiment with and see what it's like to utilize the DBT MCP server to create that context needed to start to build out an agent that serves the needs of your organization and can actually begin to calculate the different metrics and provide insights efficiently and effectively. And with that, I'll hand it over to Rob for one last connect. Thank you, everyone.
All right, just wanted to thank Dakota and the phData team for that fantastic kind of walkthrough. The last thing I just want to cover before we kind of end this webinar today is DBT agents. And so while we talked earlier about the DBT MCP server, DBT platform is also working on building several agents directly inside of the platform. And so what that means is that we're going to have tools such as an analyst agent, discovery agent, observability agent, developer agent, and even more over the upcoming months that are going to be able to solve specific parts of the ADLC directly inside the platform. The first one I've tried is the Insights, which lets you naturally use natural language querying to generate SQL and get results. But these are really exciting in that it's going to be one of the easiest and most powerful ways to use the new DBT AI directly inside DBT platform. But thanks for joining us, and please continue to ask your questions in the chat so we can get them answered for you. And we've got a couple of next steps for you. If you'd like to connect with DBT experts from DBT Labs or phData, feel free to click on the Talk to an Expert button. Join us in January for our webinar with Omni on using the DBT semantic layer to deliver AI agents. There's going to be a link in the chat. You can register now. And then lastly, there's a survey that I also sent in the chat. So please take the 2-minute survey for us. We really appreciate your feedback and want to improve our virtual events for y'all. And then thank you again for joining us. I hope you had a great day and happy holidays.